Hey guys, joining you again from my basement to take a look at page 360, properties of exponents. And now we're looking at problem 11 and looking to see if we can simplify this. And this looks like a pretty good problem. So if you can stick with me through this one, or if you got this one on your own, holy cow, pat yourself on the back because this one looks like it's pretty involved. All right. So um, let's take a look at this. Again, this is number 11 on page 360. So the first thing I notice here is that, excuse me, I get all choked up when I talk about properties of exponents. Not really. All right. So the first thing I notice here is up top. All right, I've got a numerator and a denominator, but the numerator, we've seen this. If you watched the video for 4 and the video for 10, this looks real similar. I'm going to distribute that -3. All right. And I'm going to go just a little bit quicker this time. Hopefully you can, again, if you've watched 4 and 10, hopefully this will be a little bit easier for you. So I'm going to do everything in here to the -3rd. So right now I'm just going to leave that 3 to the -3rd. But here I'm going to go ahead and multiply those exponents. All right, on 4 and 10 I took my time and didn't do that, but now I know I'm going to kind of skip that step. So -2 times 3, that would be r to the 6th. 3 times -3, that would be s to the -9th. And 0 times -3, that would still just be t to the 0. And on the bottom, I still just have 3 and r and s. Okay? So now what can I do with this? Well, first thing I notice is I've got t to the 0 power. And anything to the 0 power, one of the properties of exponents is that anything to the 0 power, again, assuming here t is not 0. I didn't look in the directions. Hopefully they went and told you that. Because anything to the 0 power except for 0 itself is 1. All right, so t to the 0 power, this is just 1. And again, since we're multiplying, it's 3 to the -3rd times r to the 6th times s to the -9 times 1. If I multiply something by 1, it really doesn't change things. All right, so I'm just going to go ahead and eliminate that t to the 0. Again, if t were 0, then this thing can't be solved. All right, because 0 to the 0 power is mathematically undefined. It's kind of like division by 0. So here's what I've got. Now I'm gonna in 4 and 10. Remember, we had a bunch of fractions and we multiplied them together. I'm going to kind of break this apart into its individual ones. So in other words, I see these two 3's. I'm going to write this as 3 to the -3rd over 3, and I'm going to put that little 1 there. All right. All of these, if they don't have an exponent, there's an understood 1 there. So I'm going to write them all with an exponent of 1. And here I've got r to the 6th over r to the 1st. And then s to the -9th over s to the 1st. Now, if you notice, if I multiplied fractions here, I do numerator times numerator times numerator, I would get this, and then denominator times denominator. I'm going to get this answer. All right, so it's easier for me to kind of break it apart into its individual parts. Break it apart into parts. That didn't come out real well. But notice I'm dealing with my base of 3's, my base of r's, my base of s's. Okay. Now I've got a property, or we have a property of exponents that says if you are dividing things with like bases, you can subtract their exponents. All right. And that's why I broke this up into like bases, because now I can use this property of exponents. All right. So I'm dividing things with like bases, so I can subtract the exponents. So -3 minus 1, I can write that as 3 to the -4th. 6 minus 1, I can write that as r to the 5th. And then finally, -9 minus 1, I can write that as s to the -10th. So now I've got 3 to the -4th times r to the 5th times s to the -10th. All right, and now like we've done in the past, this one, I mean, hopefully this next step isn't a huge shocker to you. We can't leave it with negative exponents and still call it simplified, but now understanding that negative exponents reciprocate things. So this is 1 over 3 to the +4th. This one is r to the 5th. I don't need to do anything with that, but like I did in, I think it was number 4, I'm going to write that as a fraction. I'm going to put it as r to the 5th over 1. And here, s to the -10th is 1 over s to the 10th. So understanding what negative exponents do. And now I'm just ready to multiply. Now I'm ready to put these things together. So they were together. I broke them apart to help me see how they simplified. And now I'm going to put them back together. So top times top times top, or a good math teacher would say numerator times numerator times numerator. I get r to the fifth. And denominator times denominator times denominator. 3 to the fourth is 3 used as a factor 4 times. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So this is 81 s to the 10th power. So there is that expression in simplified form. R to the fifth over 81 s to the 10th. And like I said, if you can follow that, if you think you could do one like that, there's not much I can throw at you that's going to be much more complicated. This one was pretty involved. Negative exponents were involved. The distributive property was involved. We had t to the 0. We had a lot going on here. So if you can kind of follow the process there, you're in pretty good shape. Okay, so this was number 11 on page 360 again. Simplified form, r to the fifth over 81 s to the 10th. Hopefully that helped. Let me know if you have any other questions. Take care, guys.